In this video I'm going to be talking about transformers, and transformers are devices that are used to either step up a voltage or step down a voltage. As you can see in this drawing, we have the step up transformer and we have the step down transformer. Now the step up transformer is simply a transformer that receives a low voltage on the input and then outputs a higher voltage, while the step down transformer receives a higher voltage at the input and outputs a lower voltage. Now in the transformer design, or the way it has been done, such a way that we have windings, which is the input winding and the output winding. This is also referred to as the primary winding and the secondary winding. Now each time you hear the primary winding or the input winding, means that is where the current or the initial voltage is being applied to, and then the secondary or output is where it comes out. Now the transformer, the way the transformer is being designed, usually the winding of the input and the output do not have a direct contact with each other. They are actually separated. They, like you have a winding here and you have a winding here. In basic transformers that you see around the house, you might not see it in this drawing directly, and usually in some electrical drawing they might not even put it that way. They might just give you something like this and say, okay, this is for example, this is input and this is output. Now by common sense you understand that this is smaller than this, so that means this one is bigger. It means that whatever voltage enters here, this is the input and this is the output, whatever voltage enters here will be smaller compared to what is going to come out here. So if you have, let's say for example, 10 volt here, could be 20 volt, but I mean it is not relative just by the drawing. So your calculations, you have to know exactly what you're doing if you decide to build your own transformer. So these windings can actually come in different ratios. We have like ratio 1 to 2. It means the amount of turns you have here will be kind of half the turns you have here. That is for a step up transformer. The windings here are always smaller for the input compared to the output windings. To the voltage is being stepped up, it has to be sometimes a ratio of 1 to 2, 1 to 10, or 1 to 20, or whatever. And so applies also to the step down. It could also be a ratio of 2 to 1 or 10 to 1 and all of that. So it simply means that the amount of turns that you have here is like, if it's a case of 20 times 20 ratio 1, it's going to be like 20 turns, 20 times of what you have here. You understand? For example, if for the, okay, let's say this one now, this is a step up transformer, this is the input and this is the output, which is the primary, and this is the secondary. So for example, if this is a transformer of let's say 1 ratio 10, it means if you have, let's say, 10 turns here, is going to be, the output is going to be 10 times this 10, so it's going to be 100 turns, or rather 10 times of what is in the input. Now if it is a 1 ratio 2, it's going to be like, if this side is 10, this is 10 turns, is going to be 10 times 2, which is equals to 20 turns for this side. So what you have here is going to be 20 turns. So that is the way it. Now in transformers, sometimes when you get a transformer for that, you will see it has frequencies. We have the 50 Hz or 60 Hz, or different Hz, which is the frequency of the transformer. And it is important that you observe that, especially when you have to change a transformer, when there's an issue with one and you are asked to replace, or you have to replace it, you have to be very careful about the frequencies. Because for the low frequency transformer, for example, the low frequency transformers can handle more lines of magnetic flux. Also it can handle both 50 and 60 Hz. So because the way it is, the lower the frequency, the more the line of the magnetic field or the flux that goes through it. So in other words, the 50 Hz is able to handle both 50 Hz and 60 Hz. But when you have a high frequency transformer, it can only handle low lines of magnetic flux. So I know it is used in places places where only low frequency is required. So but if you really want to use a 50 Hz input for a 60 Hz transformer, I mean there are things you can do, which could be maybe like lower the input voltage or add more turns to the primary winding. But it is important that you understand that if you just apply a 50 Hz, which is input of 50 Hz to a 60 Hz transformer, that it is going to generate heat as a result. That you are careful and watch out to see if your transformer, whenever you're changing a transformer, if it is a 50 Hz transformer or a 60 Hz transformer. Now, to calculate the turns, like I talked about this one in the first place, about when I talked about the ratios. You know, this ratio, the amount of turns that you have here and the ones you have here, sometimes it is not actually just direct calculations where you say, okay, if I have 10 turns here, I'm going to have 10 times 20 and all of that. Though we have a formula for that that it can be used, which can be stated as, let's say, Vx all over Vp to Tx Tp. Now this is the voltage of the secondary and voltage of the primary over ratio of voltage of the secondary to that of the primary, and then the turns in the secondary to that of the turns in the primary. So for example, if you are looking for the output voltage for the secondary, so it's Vs, and the input voltage is Vp is equal to 120 V. So, and then the turns for the input, or maybe let me just cancel out this, just 120 volts, and then for the input you have let's say input secondary turns is like let's say 20 turns, and then the primary turns is 10 turns. Now you need to know what the output will be. You simply cross it, so Vs, which is the secondary, the secondary voltage, which is the output, becomes equals to 20 over 10 multiplied by 120. So when this cancel this, it's basic mathematics, so this becomes 240 volts. So it's as easy as that. That is how you get to find out what will be the output voltage in a transformer that that has an input of 120 volts. The secondary turns is 20 turns, while the primary is just 10 turns. So that is how it is being calculated. And also, however, the turns can also be affected by the wire gauge that is used. So if you use a smaller wire for the input, and then you use a bigger wire for the output, the turns can be affected. So it might not necessarily follow this formula that we have here, because maybe whereby you are using a small gauge wire and you have like 100 turns here, and then you want to maybe output something bigger, you are using a bigger gauge wire, you might not actually double this. It might even be smaller, but because it's a bigger gauge wire, the output might be even bigger than what is supposed to be, compared to when you use the same gauge of wire for the input and the output. So that should be taken also into consideration. So it's not just the number of turns, but also the gauge of the wire that determines the output. So if it's a step-up transformer or if it's a step-down transformer. So it is important that we understand that. So there are a lot of things that one might want to know about transformers.